Hello class. This is the last section in chapter 2. If you've made it all the way here, fantastic. We are going to be doing all of the applications. This is marginal analysis in business and economics and using the derivative in these subjects. We're going to talk about marginal cost, revenue, and profit, and how to solve these problems using the derivative, which is why I skipped through a lot of the examples concerning this topic in the previous sections. So, marginal refers to the instantaneous rate of change or the derivative. And so we have the total cost. We've found the cost function, right? They usually give you that. And the marginal cost is the first derivative of that function. So if you take the derivative of the cost function, you now have the marginal cost function. All right. So just like you have the revenue, and remember revenue is equal to X times P of X, right? The price, the amount of product that you sold times the price that you sold it at. And so the marginal revenue is just the derivative of the revenue function. R prime of X is the marginal revenue. And last but not least, our marginal profit. Our profit is equal to the revenue minus the cost. And again, the marginal profit is just the derivative of the profit function. All right, so for all of those explanations, let's take a look at marginal cost and exact cost. So it's still, again, a lot of definitions that we're looking at here. We're going to assume that the cost is the total cost of producing the X number of items. Then the exact cost is equal to the first item minus the total cost right here. Producing X plus the first item is this right here circled in red. So the marginal cost then is the approximation of the exact cost, and it is the derivative of this function that we found earlier. Similar statements are true for the revenue and the profit function. So here we see a marginal cost and the exact cost, and we have this approximate derivative here of the exact cost. And here is our function in blue, and notice we have the tangent line at delta x, and here we have this next point following here, and that is our exact cost. And so the marginal cost is this information right here, the difference between the tangent line, right, and the tangent line and the previous point. So let's take a look at an example, and I'm going to try to move through quickly without, because they're just examples. Not a lot of explanation needing to happen. So they give us our cost function. Typically, a problem will give you our cost function, and this is the cost of producing an electric guitar right here. So we're going to find the exact cost of producing the 51st guitar. Okay, and then we're going to use that marginal cost to approximate this cost of producing the 51st guitar. The exact cost is this, right? We do C of X plus 1 minus C of X. And so we're doing C of 51 minus C of 50. So again, we're doing the exact cost here. All right, so all you have to do is plug in 51 into C of X right here, this equation, and that should give you $5,449.75. Now, if you plug in 50 into this original equation here again, you should get $5,375. So the exact cost of producing the 51st guitar is $74.75. Now, if you just take the marginal cost, so all you have to do is take the derivative of C of x, and you're left with C prime of x. So I'm actually going to take the time and do the derivative here. So if we look at this original function, and this original function here, the derivative of 1000 is 0, right? The derivative of 100x, remember this is like x to the 1, and so you bring the 1 down, and x to the 0 power is 1, so this is just 100. And then you bring this 2 down, so 2 times 0.25 is 0.5, and then x to the 2 minus 1 is just x, which is what we have right here, okay? And so that's taking the derivative of the original function. And if you do that, all you have to do is plug in 50, and you can see that the marginal cost of producing the 50th guitar is $75, which is very, very close to the exact cost. So the approximate cost. All right, so let's take a look at the marginal average cost. So if X is the number of units of a product produced in some time interval, then the average cost, right, is just C of X, the cost, divided by the number of items. But the marginal average cost is just, you take the derivative of that value. So whatever this is right here, you take the derivative of it, dx, and that is your marginal average cost. So again, some more definitions. There's the marginal revenue per unit. So notice that the average revenue, per unit is indicated by this line, and the previous average cost is also indicated by this bar over the function. And so the marginal average revenue is the derivative of your average revenue function. So, and the last but not least is our average profit function. So the average profit function is just the profit divided by the number of items sold. And so the marginal average profit is just the derivative of that profit function. So notice if you see marginal, you know that's the first derivative of a function. All right, so warning, stop. We will stop here and I will read you this message. To calculate the marginal averages, you must first calculate the average by dividing by x, and then, and only then, and then find the derivative. If you take the derivative first and divide by x, you will not have any useful information, okay? So let's take a look at the total cost of printing X amount of dictionaries. So here's our cost function, 20,000 plus 10x. And we're going to find the average cost per unit if 1,000 dictionaries are produced. And so here we're going to find the average cost by first taking C of x divided by x, and that gives us 20,000 plus 10x over x. So what does that look like? If there's 1,000 dictionaries printed, well, that means the average cost is $30 per dictionary, okay? So what is the marginal average cost at a production level of 1,000 dictionaries? Okay, so let's find the marginal cost, and again, it's the derivative of our average cost function. And I'm going to go ahead and move this through. Now, we're going to do two different things here. Let's take a look at this function up here. We're going to split this up into two parts. So this is 20,000 divided by x. plus 10x over x. Okay, and that simplifies out to 20,000 divided by x plus 10. And then we're going to move this up so that we can use the power rule. And so that now becomes 20,000 x to the minus 1 plus 10. And so we're actually going to take the derivative of this function right here, and we can use the power rule as well as the constant, the derivative of a constant rule. And so the power rule happens where this comes down and you have negative 1 times 20,000 x to the minus 1 minus 1, and the derivative of a constant is 0. And so now we have our answer, which is negative 20,000 x to the minus 2. We can bring that back down and this becomes x squared. And so once we have this function here, we can plug in 1,000 for the amount of dictionaries produced. And so minus 20,000 divided by 1,000 squared, and that gives us negative 0.02. This means that if you raise production from 1,000 to, I believe it's 1,001, the price per book will fall approximately 0.02 cents. So let's use the results from numbers 1 and 2 to estimate the average cost per dictionary if 1,001 dictionaries are produced. So the average cost per dictionary as found from number 1 is $30. At 1,000 dictionaries, we have it's $30 for the average cost to make a dictionary. Now the marginal average cost, which is the derivative of the average cost, falls for every dictionary after 1,000 dictionaries. So the average cost per dictionary for 1,001 dictionaries would be the average cost for 1,000 plus the marginal average cost, or $30 plus minus 2 cents. And so the average cost for 1,001 dictionaries is $29.98. I'm going to move ahead and do the profit and I believe there's revenue first and a profit example. So we're going to find the revenue function in terms of x, and I think I skipped the previous slide there, but you see that the revenue is just the amount of items times the price. And I think what this probably was before was x times 300 minus x over 30. And so this being your P of x function. Okay, and so the revenue function is found. This is the simplified version. Okay, now let's find the marginal revenue. So again, it's just the derivative of this function here. So the marginal revenue is the derivative of our revenue function. And so again, we're going to use the power rule and the constant multiple rule. And so again, the derivative of x, we're going to pull out that 300 x. If you have the 1, you bring it down here, and this becomes x to the 0 power, which is just 1, and that leaves us with 300. And then here we have, we're going to look at this a little bit different, negative 1 over 30 times x squared. And so then you bring that 2 down, and this becomes 2 minus 1. And so 2 over 15 gives us minus 1 over 15 to the x. And that's what this is right here. And so there is our marginal revenue. Let's find the marginal revenue for 1,500 items sold and interpret the results. And so at a production rate of $1,500, it will increase the revenue by approximately $200. So 1,500, the only place you put that 1,500 is right here. So 300 minus 1,500 over 15, which is just 100. So 300 minus 100 will give us $200 increase in revenue for making 1,500 items. So let's take a look at this function. What does this look like? And let's find this break-even point. Okay. So you can see that the cost function is linear. If you remember, the cost function is linear. And then we have our revenue function, which is squared. And so we have this parabola here. And so our break-even points are here at 600, and then here again at, looks like 7,500. Can't see the other side because my video is covering it up. But this is what you would look for. You'd graph both the cost and the revenue function. You can do that in Desmos. And the points at what they intersect is your break-even points. So let's take a look at profit, and that will be the end of this video. Profit, right, is the revenue minus the cost function, and they found that here. They took our revenue function and they subtracted it from the cost function and they simplified it. So the revenue minus the cost function gives us our profit, and that's this guy in the red box. So the marginal profit is just a derivative of our profit. And so notice we're going to take the derivative. This is a constant, so this becomes 0. 270 times x. The derivative of x is just 1. And then again, we took the derivative of this in our last function, and that just becomes x over 15. Okay, and so they just rearranged everything. 270 is positive, so the derivative of our profit function is 270 minus x over 15. And so what is the profit for making 1,500 items? And interpret the result. And so our profit is $170 per set. At a production level of 1,500 sets, the profit is increasing by about $170 per set. So all you had to do was plug in 1,500 right here.